Hello everyone. In this video, we are to see about orthographic projection. In the previous video, we saw about types of projections. Orthographic projection is an important one because we get the true shape and dimension of the object. In order to explain an object in orthographic projection, we may need multiple views. Mostly, we need 2 or 3 views. These views are obtained on planes. So this is a multi-view projection where we get exact shape and size. These views are obtained on planes. There are 2 principal planes. Here we have a vertical plane and another horizontal plane. If we look at the sunset, we see the sea and it looks like there is a meeting point between the sky and the sea. A line is seen that is called horizon. Horizon, horizontal. Just for understanding to remind. This is very important. Horizontal. Horizontal plane. That's why we call this HP. Whereas this one is vertical plane VP. Horizontal plane and vertical plane. These 2 planes are perpendicular to each other. Again, these are not real. They are imaginary. It is considered to be transparent. This is a model of this. A horizontal plane, a vertical plane. It's transparent. If we look at from this position, an object here can be seen. Now, once when we have these 2 principal planes, we form quadrants which are very much familiar to us. We call it as first quadrant, second quadrant, third quadrant, and fourth quadrant. That is what is drawn here. If we have a component here in the first quadrant, say to be a cone, if we look at from this position, that is held to be observer. Another one important thing. What about observer? If we want to look at an object, we need to be positioned at one point, right? If we look at an object from a close range, we look at in a way, it looks like a bigger one. The light rays, the projectors are somewhat like light rays. The light rays need to be parallel in order to get the true shape. Already we have stated that we get true shape and the dimension, right? So the observer is moved further away. Once when the observer is far away, the light rays tend to be parallel. The observer is at infinity, the light rays are parallel. Of course, if the observer is at infinity, the object is not seen, but we consider so. The projectors are parallel, that's the important thing. Projectors are parallel and these projections are made on planes. The projectors are perpendicular to the principal planes. That is important. So if an observer is looking at from this direction, he can see an object in the first quadrant or in fourth quadrant or in second or third quadrant because this is transparent and he is watching from this position. From this position, the view what we get is projected on vertical plane and it is called front view. The front view is obtained on the vertical plane. Meanwhile, the observer can be located at this position. So, he'll be able to get the object's top view. The top view can be projected on the horizontal plane, wherever the object is held. The top view is obtained on the horizontal plane. In the same fashion, projectors are made perpendicular to the horizontal plane. Now, we look at the objects are considered to be transparent. That's another important thing. For example, I have a 3D glass. Here we know that it's like a prism. Here we have 3 edges seen, 3 lateral edges seen. Meanwhile, we know that there is another edge. As this is transparent, we are also able to see this one, right? If it is made of wood, definitely we will not be able to see the thing which is behind. In projection, we mark the visible edges and of course the boundaries as well. Sometimes a component may be having surface which create boundary. For example, a sphere. It creates boundary, right? It doesn't have any edge. So the boundaries and also visible edges. In addition, we mark the hidden things and other details. So visible edges, hidden edges are marked, boundaries and visible edges are marked. So the observer looks at and the projection is made here. Now, we look at one by one, considering the first object. It is held in the first quadrant. The object is placed above the horizontal plane and in front of the vertical plane. Observer looks at and a cone is seen as a triangle. So that is obtained here. In the same fashion, if you look at from the top, we'll be able to see this is a circle. So this is the top view and this is the front view. In the same fashion, if a cube is placed in the second quadrant, the observer can look at and he will be able to see it because it's a transparent plane, right? So this will be seen in this fashion as a square. The cube can be held in different orientations. Here it's a simple one. So placed parallel, so we get it as a square. In the same fashion, when we look at from the top, that can be projected here on the horizontal plane and we get it as a square again. If we have a sphere on the third quadrant, we'll be able to get a circle in the vertical plane and a circle again on the horizontal plane. That gives the front view and top view. Here we are considering a cylinder that is below the horizontal plane and in front of the vertical plane. There too we get a circle on the top view. In the front view we get a rectangle. Looking at these things, look at here we get a circle, here we get a circle, here we get a circle. That's why we say that single view may not be sufficient. Multi-view projection. A single circle can be of anything. It can be a circular disc, it can be a cylinder, it can be a sphere, it can be a cone, or even it could be a hemisphere or so. So a single view is not sufficient to predict. That's why we need to have multiple views. Here we have first angle projection, second angle projection, third angle projection, fourth angle projection. Object can be projected by having it in any of the quadrants, right? Whether all these are accepted, which one do we need to follow? There are questions. We'll be able to solve that one in the upcoming video. Thank you so much.